Welcome to Maths with EJD. In this video, I'll be talking about the mixed strategy Nash equilibrium. Two videos earlier I've talked about Nash equilibrium using prisoner's dilemma and of course the battle of the sexes to show in the case of the prisoner's dilemma, one equilibrium, Nash equilibrium, but in the case of the battle of the sexes, we had two equilibria, right? So here we are beginning to we'll look at mixed strategy and how that plays into the idea of Nash equilibrium. Okay, so first, let's start with the definition. So, a mixed strategy, Nash equilibrium. After now, we'll just call that MSNE, MS, MSNE, mixed strategy Nash equilibrium, occurs when players randomize their choices among available strategies. So it means there's no fixed strategy like that. So there's a set of strategies available that can be chosen from. So when players randomize their choices among available strategies, assigning probabilities to each action. So in the case of mixed strategy, we have a probabilistic situation. So this ensures that no player can improve their expected payoff. I mean, this is the Nash equilibrium part now. This ensures that no player can improve. The probabilistic part is the mixed strategy part, while this part where we're ensuring that no player can improve their expected payoff is the Nash equilibrium part. So this ensures that no player can improve their expected payoff by unilaterally changing their strategy. Because this is simply because the payoff at this point is actually optimal. Nothing else can be done to it to make it better. So this takes us to the idea that let's consider the importance of the mixed strategy Nash equilibrium. So in this case, we have a measure of unpredictability. Unpredictability because it's mixed strategy. So here we talk about randomizing. Randomizing prevents opponents from exploiting predictable behavior. From exploiting predictable behavior. So that's the importance of mixed strategy, right? So the opponent doesn't know necessarily what you will do for sure. And then the other part is the applicability. Applicability. So here, uh, this kind of idea is used in economics, military strategy. It's particularly important that in military, your opponent don't know what you are going to do. So used in economics, military strategy, sports, and more. And then we have resolution of indeterminacy. Resolution of indeterminacy. Okay. So in this situation, right, uh, mixed strategy Nash equilibrium provides to actually provides solutions in games without pure strategy equilibrium. Okay. So now let's talk about the steps. Steps to calculate mixed strategy Nash equilibrium. Steps to calculate to calculate mixed strategy Nash equilibrium. So the first thing is to define the game. Define the game. So and by that we mean identify the players, identify players, strategies, and payoffs. So that's how to define a game. You need to know the players, the number of players there, their strategies, and their payoffs. That's how you define a game. And the second thing is to assign probabilities. Assign probabilities. So here you assign probabilities, e.g., you can have like PQ for each strategy, ensuring this sum to 1. So the whole idea of PQ is that, for instance, the probability that in a prisoner's dilemma game, the probability that you will cooperate can be P, while the probability that you will not cooperate will be Q. So that by the time you add P and Q together, everything will be 1. So if the probability that you will cooperate is 0.7, the probability that you will defect will be 0.3. So P is 0.7 while Q is 0.3. And that way, the two can sum up to 1. So you can assign probabilities like that. Then 3, you can check the equilibrium condition. We already know how to do that, right? Equilibrium condition. So you check the best responses for each player, under whatever circumstances, no matter what their opponents do, right? You check for their best response in whatever situation. So this in this case, you ensure players randomize in a way that makes others indifferent between their available strategies. So the basic idea here is that you are going to do something such that whatever your opponents do, it doesn't really matter because you have an upper hand or something like that. Then the fourth point is to set up equations. So this one involves equations now. Set up equations. So in this case, you're going to use expected payoffs. Use expected payoffs to derive equations. Use expected payoffs to derive equations. Then 5, you can solve and verify. Solve the equations you have set up and verify. Solve and verify. So here, you solve for probabilities, ensuring they are non-negative. Ensuring they are non-negative. And sum to 1. Okay. All right, so those are the procedures you need to follow for to calculate mixed strategy Nash equilibrium. Okay. On a final note, right? We need to ask ourselves the question: Why use mixed strategies? Why is that necessary? So why do we need to use mixed strategies? So here, when no pure strategy, when the pure strategy equilibrium exists, mixed strategies ensure stability. Mixed strategies ensure stability and optimal outcomes for all players. Okay, so mixed strategies are that important. In the subsequent videos, we'll be looking at, I will use this idea of mixed strategies for a rock, paper, scissors game. And of course, we'll also use the mixed strategy Nash equilibrium for matching pennies. So look forward to those videos. Because you don't want to miss those videos, you definitely want to subscribe to this channel. And then hit the notification bell so you can always get alerted each time a new video is released. And of course, you want to comment and let me know if you want to teach a topic or solve a problem. Then like and share so that more people can have access to this great learning. Till I come your way again, keep playing the game of life with wisdom. Bye.